I'm Fauwaz Hanbali with the Water Management Systems Division at HEC. I'm going to talk to you about HEC-DSS and gridded data management. This is the second part of the presentation, focusing on gridded data storage in HEC-DSS. In this part, I will talk to you about the DSS gridded data's header information, or metadata, the gridded data structure, and naming conventions in HEC-DSS. The header data for an HEC-DSS gridded record has important attributes that help with how the data should be interpreted and used. There's the grid cell size to represent the data resolution, the grid system's definition with the origin, cell, location, and number of rows and columns. The assigned coordinate system is included in the header to help with geospatial handling of the gridded record, and the start and end times for each gridded record, along with the data type attribute, help determine what type of statistics and calculations would apply for the record. In addition to the header information, the other part of gridded records data structure is the data array. The data array for a gridded record is stored as a list of sequential values, just like an array for an HEC-DSS time series record. But the geographic header information for the gridded record help with the interpretation of the size of the grid, the geographic location, and how the data values from the array are assigned to each cell in the grid, starting from the lower left cell. Now, the conventions for the HEC-DSS gridded record path names are a bit unique. The A part is dedicated for identifying the grid system, either HRAP, SHG, or UTM. The B part is for identifying the location, like a region or watershed. The C part is more conventional. It's for specifying the parameters such as precipitation or temperature. Then the D and E parts specify the duration of the record. Both the D and E parts would be specified for a grid record that's either period cumulative or period average. But for instantaneous records, only the D part would be specified, with the E part left blank. And then the F part, that's the version identifier for the record. Typically, the product type is used, for example, stage 3 for observed precipitation, or QPF for forecast precipitation. Cataloging gridded records in HEC-DSSVue is alphanumeric based, not time interval or date based, so filtering by path name parts can be challenging in DSSVue. Using the search path names by string filtering option can be useful enough, but for more sophisticated filtering, HEC-MetVue is easier to use, and we'll take a look at that in the next part of the presentation. There's a very basic grid plot in HEC-DSSVue. It doesn't have a color scale legend, but there's a tooltip display of grid cell values when hovering the cursor over the plot. When selecting and plotting multiple grids from the DSSVue catalog, the plot will include DVR controls to step through the display of each record. That's useful for general inspections of the record, just to make sure they have data, but for more helpful visualization analysis, HEC-MetVue is best. The header information for a gridded record can be reviewed by tabulating the record from the DSSVue catalog. There's a concise grid information table called grid info that has just the basic header information. That's the grid type, the start and end times, data units, data type, and grid extents and cell size. Some basic statistics are also provided for the minimum, maximum, and mean cell data values. There's also a detailed grid info table that has more header information, such as the grid type, HRAP versus SHG or UTM, the number of rows and columns for the grid, range of cell value statistics, and the coordinate system definition. This is the end of this part of the presentation. If you have questions about our software, need some help, or are looking for additional training, please check out the links below, and thank you for your time.